Alright, so we're going to talk about constructing our confidence intervals, dealing with means, and go through the four-step process. So in doing this, let's talk about this problem right here. We got to talk about some Oreos today. So we're going to estimate the average weight of an Oreo cookie to determine if the average weight is less than advertised. We selected a random sample of 30 cookies and found the weight of each cookie in grams. The mean weight was 11.1921 grams with a standard deviation of 0.0817 grams. So let's make a 94% confidence interval to estimate the true mean weight of Oreos. Okay? Or weight of an Oreo. Alright, so starting out with this, we're going to go with dealing with our state, plan, do, and conclude. Alright, so we're going to start with the state part. So dealing with this, our state part, we worked on dealing with we calculated what our population was. We talked about what our parameter was. And then we talked about what our sample was. And we had to determine what our statistic was. Okay, so we're going to do that in dealing with means. So this will be a little bit different on a couple of figures, okay? So with this, the population, in this case, when we're talking about Oreo cookies, the population is all Oreo cookies, right? So all Oreos. The parameter, in this case, since we're talking about the mean weight of an Oreo cookie, the parameter is the true mean weight. So in this case, our mu, alright, so the true mean weight. True mean weight. Now, the sample, of course, we said our sample right here says sample of 30 cookies. So we should go back and read the problem or what we talked about doing here. So our sample was 30. In this case, I'm going to go ahead and say what our done is Oreos. Okay. In other words, you could also simply say sample n equals 30 for your sample size. And dealing with our statistic, well, our statistic was given to us because when we did this and weighed each of the cookies and we found out the mean weight for these 30 cookies came out to be 11.1921 grams. So our statistic, our x bar, is going to equal 11.1921. So again, with these, the only two things that have changed is on our parameter. Instead of having a proportion, a true proportion, we have a true mean. And in this case, we're going to be dealing with statistic. Instead of having a p-hat, we have an x-bar. Because a p-hat is dealing with a proportion. We're dealing with the means. We're talking about x-bar. So there's two things that changed in the state part of this. Alright, so let's go on to our state plan. Alright, state plan, do, and conclude. So we'll go on with our plan part. So we're going to go with plan. Alright, so in this case, we have 3 conditions we need to meet. Alright, so with that, your first condition, so let's write conditions right here. Alright, so conditions, and we'll say number 1 here is, we want to know if we had a simple random sample, right? We want to know if we had a simple random sample. In this case, we said we took a random sample of 30 cookies. So since we took a random sample of 30 cookies, this checks off. Our second condition we're going to look at, we want to find out if we pass the 10% condition. Condition number 2 is going to be our 10% condition. This allows us to use the calculation or the actual formulas to do our calculations. So this has to check off with this, right? So our 10% condition. And for this, we should say that we have our sample size was 30. Now we're going to say if that's less than 10% or 1/10 of all Oreos. And I sure hope that 30 Oreos is less than 10% of all Oreos. So we should check off that guy right there. And our third condition is going to be to find out if we have a normal, approximately normal, okay? So we want to see if we have an approximately normal. So we're going to write that out right here, just as far as approximately normal. We want to find out the shape of our distribution. So we want to see if we have approximately normal. Now, in dealing with proportions, we did large counts. And with means, we're going to deal with the central limit theorem. In other words, that our sample size is greater than or equal to 30. Well, in this case, we are right on the edge of that, right? So we had 30 cookies for our sample size. So our sample size was 30, and that was greater than or equal to 30. So that checks off. Therefore, then we would write approximately normal. So approximately normal, and that's for the distribution of these as well. Now the last thing we need to write in this for our plan part for the conditions, well, before the conditions, we need to have a name for this, because remember in dealing with proportions, we had name the actual procedure we're going to do for this. So in this case, for the procedure we're going to do with this, we're taking a one sample, right? We said we're just going to do one sample of 30 cookies. So we're taking a one sample t interval for the mean. So under the plan, this is going to be classified as the one sample t interval. We'll talk about the t in a second. T interval for our mean, our mu. So again, that's the name of the procedure. So I'll write that in red here so it makes it a little bit. So this is the name of procedure that we're going to do to find out the confidence interval. So with this, we have a one sample t interval for the mean. If you remember for the proportions, we had a one sample z interval for the proportions. And that's because we used a z star in calculating this to find our margin of error. In this case, we're going to talk about it under the t star. And we're going to go on that dealing under the do part, which is what we're going to tackle next. So we got the state part, where we dealt with our population parameter, sample, and statistic. Our plan part, where we named the procedure, and then we did all three of our conditions. We had a simple random sample that we listed, a check mark. We had a 10% condition. We listed out, we had 30, which is less than 10% of all Oreos, check. And we made sure it was approximately normal by checking the central limit theorem, or the means. In other words, we had a sample size of greater than or equal to 30, which made it approximately normal. We have to list all three of these conditions and name the procedure for the plan part. Once you've got that, then you're good to move on with the do part, because now you've been able to clarify that you can use the formulas that I'm about to show you, and that you have a normal distribution, approximately normal distribution, to be able to do this. So now, the do is where a couple things kind of change for us, alright? So we still have our same formula to calculate for the margin of error, right? Everybody should remember we have our point estimate plus or minus our margin of error. Alright? Now with this, your point estimate is going to be your x bar, plus or minus your margin of error. Now the margin of error is what changes up here. So for your margin of error, okay, let me just different color just so it makes it a little bit easier to follow. Okay, so we're going to do margin of error. Margin of error is going to be, in this case, your t star times your standard error. Okay, so with that, we're going to have to do a little extra calculations to figure this out and look at a couple different areas. Okay. All right. So first off, to find the t star. So to find this, it's going to take a little bit of an extra step here, because it doesn't just worry about being 95% confidence like we had to deal with in dealing with our z star. So for the t star, you're going to worry about degrees freedom and your confidence interval, or your confidence level, I'm sorry, confidence level. Okay, degrees freedom is always going to be your sample size minus 1. Your confidence level, in this case, what we dealt with, what was listed, I should say, the problem is 95%, or 95% confident, alright? So for our degrees freedom, in this case, our sample size was 30. Subtract 1, of course, we're going to get 29. And our confidence level is going to be 95% still, not changing anything to that. To do this, dealing with, if you have a TI Inspire, you're going to go with, to find your T star, your menu, 6, 5, 6. And let's see what that looks like. So if you have a TI Inspire, you can simply go in here and menu, and we're going to go 6 statistics, 5 distributions, and 6 for inverse t. Now I want to know area and degrees of freedom. So in this case, you can simply type in our area is the same type of calculation that we had to do with for our z star. So your area is going to be 1 minus 0.95, so the percentage of your confidence, right, divided by 2. Well, and that'll give us 0.025, because we have a 0.05 difference divided by 2, so give us 0.025. So in our calculator, area is 0.025, and our degrees freedom was 30 minus 1, so 29. I'm going to enter twice here. And that should give us this value right here. Again, disregard the negative for this, because we're going to simply say this is for 2.045. So for our T star, we should get 2.045. Now, if you do not have a calculator, a TI Inspire I should say, you can look this up by using this table here, which I have put in Canvas for you to look at. And with this, we're going to go with dealing with our degrees freedom. It's right here. Okay, so it's degrees freedom. Sorry, I kind of marked it out. Let me try a little bit different here. Degrees freedom. And then you're going to go with the numbers here are area that we just calculated. So as you can see, we calculated 0.025 for our area. So we're going to look at this column right here, and we need to find the row for the degrees freedom of 29. So here's our 29, and we're going to be looking at the 0.25 column, which gives us this value right here. 2.045. Oh my goodness, I didn't start that good at all. 2.045. So it gives us the same exact value that we got in our calculator. Alright? So for that, we are good then. So you can either use, again, your TI Nspire by doing menu 656, or you can use this, I have labeled here for table D, okay? And so if you're going to look at using table D, we still got our T star to be 2.045. Okay, so those are both good. Now we need to worry about our standard error of this sample mean, right? Well, let's go ahead and get a different color here. Alright, so for our standard error of this, we're simply wanting to find standard deviation of our sample, right? Well, to calculate that, we're going to take the standard deviation that's given to us and divide by the square root of our sample size, which you guys have played with already in previous lessons we've done with, but now it's just making it, classifying it as our standard error to calculate our margin of error, okay? So for this, they said our standard deviation for the overall setup here was 0.017 or 0.0817, okay? And then we're going to divide that by our square root of 30. So for our standard error of our sample, we're simply taking 0.0817 and dividing by square root of 30. And therefore we should get, let's see, what did I get here? 0.0149. 0.0149. Okay, so now we have two very important values that we need. We have our standard error value, we have our T star value, and we already have our point estimate, our X bar, right? The actual mean weight from our samples. So to do that then, let's go ahead and write that out. So for our X bar, point estimate, we got 11.1921 plus and minus our T star of 2.045 times our standard error of 0.0149. And when you do this by doing the plus first and the minus, well, let's just say plus and minus. Let's go with the lower value first. So our lower value, to list this out, is going to be, we did minus first, so we did 11.1921 minus 2.045 times 0.0149. We should get 11.1616. And if we did a plus instead of a minus, we would get 11.2226. Okay? So again, that is our interval. So that is our interval that we're looking at. We're saying that the weight should be 11.1616 grams to 11.2226 grams, and we're 95% confident that it should fall within that range. Okay, So now that we've got that, now we just need to interpret it, right? We're going to conclude with this guy. So now we've done state, plan, do, and conclude. It's our last setup. Okay. So with this, when you have your interval, which I'm going to go and write our interval over here real quick, just so I can make sure we got this set up here. So again, it was from 11.1616 to 11.2226. All right. And for our conclusion, we simply just need to say we are 95% confident that the interval from 11.1616 to 11.2226 grams captures the true mean weight of Oreos. So we are 95% confident So we are 95% confident that the interval from 11.1616 to 11.2226 grams, make sure to include the grams for what you're talking about, captures the true mean weight of Oreos. So you got to include the context there as far as what you're talking about. So you're 95% confident that interval you came up with captures the true mean weight of, in this case, Oreos. All right. Now the last thing you may be thinking about is, well, what are they claiming is the true weight? Well, the true weight that we're going to say that Oreo is telling us, we're saying that their overall weight is 11.3 grams. Well, does that fall within there, or is ours lower than this case? Well, in this case, yes, our interval is below 11.3 grams. This 11.3 grams does not fall in between there. It doesn't fall in between our 11.16 to 11.22. So therefore, our interval is below this value, which in this case is what we were trying to figure out. Again, we're trying to see is less than advertised, right? We're trying to see if it was less than advertised. And in this case, for what we found out from dealing with our sample of 30 cookies, that is the case. Alright, so that deals with creating a confidence interval for dealing with means and talking about your state, plan, do, and conclude. And yet all four of those steps need to be done when talked about creating a confidence interval, because that shows me that you understand that you're dealing with approximately normal, and then it checks off for the value to use the formulas we used, and therefore you can create an interval and conclude by telling me how confident you are with that interval. Alright, so I hope you learned a little bit some of that, and I'll see you next time.